Hello everyone, my name is Harshit Vadavkar and my selected topic is Health Big Data Analytics, a technological survey. Big data in health. Healthcare is a very data intensive field. The data generated cannot be handled by traditional EMR records based software. Hence, there needs to be a software which is capable of handling a large amount of data or which is known as big data. The health data has become very ubiquitous because of improvements to recording systems in healthcare, the participation of patients in the treatment using social network, as well as the introduction of cyber physical systems in healthcare. Hence, the field of big data and computational intelligence promises a bright prospect in building state-of-the-art health systems. Currently, a big data, which is being used in healthcare sector, comes in prevalent forms and swiftly emerges from divergent platforms. As there is an urgency to take prompt action in case of a medical emergency, the analytics system must be able to aggregate all data and provide insights to the physician in real time. The health big data comes from both structured data sources such as EMR and insurance providers' databases, as well as unstructured forms as doctor's notes, prescriptions, IoT devices like wearable devices, medical sensors, electronic monitors, mobile applications, social media, and research registries, etc. While straightforward algorithms such as decision trees and k-means can be used to solve forthright tasks such as deciding whether the patient should be hospitalized or not, certain tasks like those involving applications of MRI scans or differentiating cancerous tumors from benign ones required sophisticated algorithms such as convolutional neural networks. Hence, the choice of a technique for a given health instance requires a thorough analysis. In this review, the authors provide an option to choose from, the algorithms to choose from depending on the health predicament. Challenges in big data analysis. The system should not only be able to help for the provision of a successful and timely care by recommending a practical diagnosis which has worked well against similar cases, but it should also be able to predict the possible medical aggravations that might occur. This includes using complex events processing or CEP for the determination of disease progression, which can help to stop it at an earlier stage of development. The challenges in big data analysis come in different stages. The main challenges include data aggregation, the data maintenance and storage, data integration and interoperability, and the time taken for the data analysis. Sources of data. The health big data can be obtained from various different sources which may have structured as well as unstructured data. The main sources of health big data are given here. The first one is EMR or EHR, which stands for Electronic Medical or Health Data. It is the primary health big data source. The second one is Medical Internet of Things or MIoT and cyber physical systems, which uses various sensors, for example, electrocardiogram or ECG and EEG, etc., to record health parameters of the patients in real time. Then, social network data can also be mined, which can reveal crucial medical information about the patients. And another one is genomic data, which is the DNA data from organisms, which can be analyzed, and analysis of this data can lead to various breakthroughs in genetics. Data mining techniques. In the last decade, various methods have been used to explore and find patterns and relationships in healthcare data. Different techniques are effective when applied to different situations. Some of these techniques include K nearest neighbors, which is effective in classifying a disease by matching it with already known cases and the resulting complications. Support vector machines, which are very effective classification algorithm, which uses hyperplanes for dividing into different classes. Neural networks are currently already in use for complex medical operations like medical imaging, such as brain lessons analysis, fetal imaging, and cardiac analysis. Then, ensemble learning. Uh, the medical problems are usually very complex, and a single learning algorithm might fail to yield an informative result. Hence, we can combine many different learning techniques into a more effective and robust learning technique, which is better than its individual constituent algorithms. An ensemble is a collection of various learning techniques working together in parallel or in sequence to produce better results. Platforms. Building a scalable health analytics is very complex because the data can vary in speed, size, urgency, availability, and many different parameters. To scale and accommodate the data, the analytics system must be integrated into a parallel and distributed computing framework. The biggest challenge with healthcare data is the diversity in its volume. The analytics must be performed proactively and reactively. Hence, the architecture must be sufficiently extensible to support all the analytics. The big challenge faced while selecting an appropriate platform to use for the analytical solution is to accommodate the urgency of action and required insights. While some data, such as ECG readings and other MIOT data, may be urgent and require in memory streaming and immediate analysis, some other data, such as HER records, might require batch processing. And though these platforms exhibit different architecture, any parallel computing platforms share components are to be considered while designing the scalable big data analytics. The following big data platforms are very popular in health informatics. The first one is Hadoop, then high performance computing or HPC clusters, Spark, Flink, and Storm are very popular platforms in health informatics. References. The link to the paper used for making this presentation is given here. The paper is available on the IEEE website. That is all. Thank you.